Welcome viewers, in this video we will see the details about priority encoder. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic priority encoder. We know that encoder is a device will having 2 to the power n inputs and n output. 2 to the power n input with n number of outputs. In this we will see what is the priority encoder. The priority encoder is an encoder circuit that includes the priority function. Out of 2 to the power inputs, the priority will be given. The output will be based on the priority of the input. The priority encoder, if 2 or more inputs are equal to 1 at the same time, the input having highest priority will take the proceedings. Right? If more than 1 digits are 1, the highest priority will be taken into account. Now we'll refer the truth table so we are able to understand. So this is there are 4 inputs available, 4 digits and 2 digit output is available. So because of 4 inputs we have 16 combination. Here 4 combinations. Right. And also one more output is available, verification. This verification used for whether all are 0 or any one is available. If all are 0, the circuit will not produce any output because no priority. So this V also 0. At least one is there, then only this term verification will be higher. Otherwise, if all are 0, the output of the circuit is nothing. It will not produce any output. So to verify if all are 0 or at least any one is available, we are using the term V. Now we'll see the truth table. So the highest priority is given for D3. If D3 is 1, whatever may be D2, D1 and D0, it will give the output as 1, 1. Right? The D3 is 1, whatever may be the remaining digits, will get the output as 1, 1. The second priority goes to D2, but D3 should be 0. D2 is 1 and D3 is 0 as the second priority. Whatever may be D1 and D0, it will give 1, 0. Right. Third priority goes to D1. If D1 is 1, D2 and D3 should be 0. Then it will give the output 0, 1. The last priority is D0. D0 is 1. D1, D2, D3 is 0. It will give 0, 0. There is nothing. 0, 0 is no output. Right. So highest priority given to D3. If D3 is 1, we will get 1, 1. If D2 is 1 but D3 is 0, we will get 1, 0. If D2 is 1, D1 is 1 and D2, D3 is 0, we will get 0, 1. If D0 is 1, other terms are 0, we will get 0, 0. So in all these cases, a minimum 1 is available. So the verification output is 1. Now we'll see the description. Table shows D3 input with highest priority and D0 input with lowest priority. When D3's input is high, regardless of the other inputs, the output will be 1, 1. If the D3 is 1, we will not bother about other remaining terms, we will get the output as 1, 1. Similarly, we have the other description. The D2 has the next priority. If D3 is 0 and D2 is 1, regardless of the other lowest priority, the input will be 1, 0. Two things. D2 should be 1, at the same time D3 should be 0. Then only we will get 1, 0. Similarly, the output for D1 is generated only if the highest priorities are 0. That is, D2 and D3 is 0, D1 is 1, we will get the output as 0, 1. Right. So, the verification. The output V, valid output indicator, indicates 1 or more inputs are equal to 1. If any 1 or 2 inputs are 1, it will give the 1 as a output. If all are 0, it will give 0 output. So that we can verify at least any 1 is available at the input. Right. Now we'll see the detailed truth table. So here 4 digits available, 16 combinations are there. Here we simply marked as XXX. The X may be 0 or 1. This X may be 0 or 1. Now we'll see the detailed truth table, that is 4 digits, 16 possible inputs and two possible outputs. Now we'll see the detailed truth table. So this is the detailed truth table. D0, D1, D2, D3, 0, 0, 0. Like this we'll have 16 possible inputs are available. 1, 1, 1. Finally we have 1, 1, 1. There are 16 possibilities available. For that case we need to check the output. Right. So first we will see the highest priority. Highest priority is D3. Right. D3. If D3 is 1, whatever may be, we will get 1, 1 as the output. Here also D3 is 1, 1, 1 as the output. Here D3 is 1, 1, 1 as the output. Here also 1, 1, 1 as the output. And here also 1, 1, 1 as the output. Here also 1, 1, 1 as the output. Whatever may be the remaining digits. Then this 1, 1, 1 as the output. Here 1, 1 as the output. So wherever we have D3 equal to 1 indicated by this red color line, we got the output as 1, 1. We no need to check the remaining terms. Right. Next priority is D2. We need to check the D2. This D2. D2 should be 1, but D3 should be 0. That is 1, 0. This is D2 should be 1. This should be 0. In that case, the output will be 1, 0. Here it is there. Here 0, 0. But here 0, 1. It's not applicable. Here 1, 0. D2 is 0 and D2 is 1, D2 is 0. So we'll got the output as 1, 0. But here D2 is 1, but D3 is already 1. This is already completed. This. Now these two. Here 1 and 0. So we'll got the output as 1, 0. These two not applicable. Then another two available. This 1, 0. So that we'll get 1, 0. Then here 1, 0, 1, 0. Right? So wherever D2 is 1, D3 is 0, we got the output as 1, 0. Then the next priority is D1. We need to see that D1 should be 1, but D2 and D3 should be 0. Then we'll got the output as 0, 1. So here it is applicable. But here not applicable. Here 1 is there. Not applicable. Here's 1. Is not applicable. There these two are 1. So only this combination will get 0, 1. This is already covered in first priority. This is already covered in second priority. This is all covered in first priority. So we'll have only this combination will give 0, 1. Similarly, another 4 terms available. D1 is here 1. But here it is correctly there. D1 is 0. D0, D2 and D3 is 0. D1 is 1. So we'll got 0, 1 as the output. These are all not possible. It's already covered. Right. The last one is D0 should be 1. D0 should be 1. So first 8 D0 is 0. Remaining 8 D0 is 1. Right. Here 1 all are zeros. So for that case we'll get 0, 0 as the output. Right. So this one 1, 0, 0, but here 1 is there. Already covered. This is also already covered. These are all already covered. So only this combination will get the last priority 0, 0. Already all are 0, 0 mean the output also 0, 0. Right. So this will give the detailed truth table. Now we'll see again one by one. See all are 0 means 0, 0. D3 1, 1, 1. D2 1, 1, 0. Here both are 1. So already this is covered. We will check only D3 1, 1. Here D1 is 1, remaining 0. So 0, 1. Like that we'll have. Now we need to go for the logical expression for y1 and y0. By using K-map, we need to find the logical expression for y1 and y0. Also the valid indicator V. For these three outputs, we need to find the logical expression using the K-map. Now we'll go to the K-map. So based on the truth table, first we'll find the K-map for y1. Here the inputs D0, D1, D2, D3. So 4 variable K-map. These inputs are framed. From the table it is marked. This one is X. 0, 0, 0. Both are 0, 0 mean it will not produce any output. That is indicated by the input valid indicator. These 3 are 0 and these are all 1. You can refer the truth table. From the truth table it is marked. So we can group these 8 cells red color and these 8 cells green color, right? While grouping all these 8 cells, these corresponding inputs are cancelled. Only we have to refer 0, 1 and 1, 1. This 0 and 1 will be cancelled. Only 1 is there. 1 means D3. We'll get a D3. While combining these 8 cells, the corresponding rows will be cancelled. Only we have to refer the third column and fourth column. 1, 1, 1, 0. This 1 and 0 will be cancelled. Only this will be 1. This will 1 means D2. Right? So D2 plus D3 is the expression for Y1. So this is based on the K-map. The video for K-map available separately. We can refer that. Now the K-map for Y0. D0, D1, D2, D3 inputs. These 8 variable K-maps are framed. We know that this first condition is 0. All are 0 means don't care condition. The remaining inputs are marked as 1 from the truth table. So there is 2 combination. We can group these 8 cells red color and we can group these 4 cells. Right. While grouping these 4 cells, we have to refer corresponding second row and third row. 0, 1, 1, 1. This 0 and 1 will be cancelled. Only this 1 will be available. This 1 means D1. This D1 is there. We have to refer the corresponding first column and second column. 0, 0, 0, 1. This 0 and 1 will be cancelled. Only this 0 will be there. 0 means D2 dash. D2 dash. Right? D1, D2 dash is the grouping of these 4 cells. While grouping these 8 cells, these corresponding rows will be cancelled. 0, 0 cancelled by 1, 1. 0, 1 cancelled by 1, 0. So the second column and third column we have to refer. 0, 1, 1, 1. This 0 and 1 will be cancelled. Only this 1 is there. This 1 means D3. So Y0 is D3 plus D1 D2 dash. Right? So we got the expression for Y1 and Y0. Now we'll go for the verification. Input valid indicator. So D0, D1, D2, D3 inputs. These are all marked. We know that this case 0, 0, 0, 0 means no output. For all other cases minimum 1, 1 is there. So all are 1. Right? Only this is 0. So we can group. This is one grouping. Green color. Red color another grouping. This is one more grouping. This is one more grouping. So where there are 4 groupings available with 8 cells. So by simplifying we got D0 plus D1 plus D2 plus D3. We will verify one by one. First we will take the green color. This green color means corresponding rows are cancelled. Only you have to reverse second column and third column. 0, 1, 1, 1. This 0 and 1 will be cancelled. This 1 will be there. This 1 means D3. Now this red color. All rows will be cancelled. You have to refer third column and fourth column. 1, 1, 1, 0. So this 1 and 0 will be cancelled. Only this 1 is there. This 1 means D2. D2 is there. Now these 8 cells. These 8 cells mean the corresponding columns are cancelled. Only you have to refer second row and third row. 0, 1, 1, 1. This 0 and 1 will be cancelled. Only this 1 is there. This 1 means D1. Now verify these 8 columns. The corresponding columns will be eliminated. You have to refer third row and fourth row. 1, 1, 1, 0. This 1 and 0 will be cancelled. Only this 1 is there. This 1 means D0. So D0 plus D1 plus D2 plus D3. Now we got the expression for Y1, Y0 and V. That can be now implemented with the logic gates. Right. Now we'll see the logic gates. So these are all the required inputs. D3, D2, D1 and D0. By tapping is taken and a NOT gate is connected, so that here we'll get the D3 dash. Similarly D2 tapping is taken, connected to NOT gate, will get D2 dash. D1 and D0 is connected. D1 dash, D0 dash is not required, so that NOT gate is not connected. So we have 8 inputs are available. D3, D2, D1, D0, D3 dash, D2 dash. Right. First we will see Y0. What is Y0? Y0 is nothing but D3 plus D1, D2 dash. Right. So here we need one OR gate. OR gate is available. One input is D3. So D3 is connected. Another input is D1 into D2. For that we need one more AND gate. So D1 is connected, D2 dash is connected. So here we will get D1, D2 dash. Here D3 available. Now these two are added together. D3 plus D1, D2 dash. So we will get the output as Y. What is Y1? Y1 is nothing but D2 plus D3. So we need one OR gate. D2 and D3 is connected. So this is added. So we will get the Y1 as a output. So Y0, Y1 is our required output. And one more output is verification. Verification V. What is the V? It is D0 plus D1 plus D2 plus D3. These four inputs are added together by the OR gate. So this is D0, D1, D2, D3. Four inputs are given, four are added together, so it will give the verification output. So in this video we discuss the priority encoder. Encoder is the 2 to the power n input and n output, n possible output. In that the priority is given based on the priority, which one having highest priority, which one having lowest priority, accordingly the output is generated. Here if D3 is the highest priority, if D3 is 1, then it will generate only 1 1 as a output. D2 is 1, but D3 is 0 means it will generate 1 0. D1 is 1, D2 and D3 is 0 means it will generate 0 1. If D not is 0 means it will generate 0 0. Based on that we have the truth table. Then we discuss the detailed truth table. From the truth table using K-map we got the logical expression. Then the logical expression is implemented with the logic gates. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.